We've got the substitution method for solving a system of equations. The first method that we used was the graphing method, in which the place where the graphs cross was the solution, but it has limitations. Okay, consider the following example. If we graph these two lines, notice where they meet is not exactly on one of our easy intersections of two values. Okay, we're going to get some sort of fraction or decimal there, and it's hard to approximate that that answer. We want an exact solution. So in order to do that, we should use a different method. So we're going to learn one of those methods today. It's called substitution. Well, what does it mean to substitute? Think about a substitute teacher. Okay? If your teacher's gone, they come in and replace your teacher so that work can continue on. So we're going to use that same idea in order to solve a system. Okay? The steps to solve an equation, or excuse me, a system of equations, are to isolate a variable in one of our equations, and you'll see this in an example. From there, we substitute the expression into the other equation and solve. The third step would be to substitute the value we get back into step one and solve for our other variable and write our solution. Our first example, let's follow our steps. We want to isolate a variable in one equation. Okay, and we want to do that as easy as possible. Okay, if I look at the second equation here, y doesn't have any other coefficients with it besides a positive 1. So that sticks out to me to be the easiest variable to isolate. And to do that, I'm going to add x to both sides. I now have y equals x plus 7. I use that equation to solve the system by substitution. Now, again, y equals x plus 7. That's what y equals. So where I see a y back in the first equation here, I'm going to substitute that value in. Since y equals x plus 7, I'm going to replace y, or substitute this in for y. So copy down 2x plus 3y. However, I'm going to skip the y equals 31. Instead of writing y, I'm going to write what y equals, x plus 7. From there, I can solve for x. I have to distribute the 3. So I get 3x plus 21. Combining my like terms, and I'm going to move the 21 over at the same time. I get 5x equals 10, so x equals 2. Now remember, when we graphed and we got an answer, our solution was an ordered pair. Okay, and ordered pairs are always x comma y. Okay, I found the x. I need to find the y. Okay, well, going to my steps. Step number 3 was to substitute that value back in to the equation from step 1. Okay, and that equation was y equals x plus 7. But I have x. It is 2. So my y part of my solution is 9. And that is the ordered pair for my solution. Do the same thing for example 2. Again, I want to choose the easiest number, the easiest variable to solve for. I see a single y. It does have a negative sign by it in the first equation, but that's okay. We can get rid of that. So to get y by itself in that first equation, I'm going to add 4 x's. I now have negative y equals 4x plus 2, since the 2 was positive. And to get the y by itself, I divide that negative 1 throughout. So the signs switch on all of my terms. So I now have a single variable y solved for. That was my first step. I now put that in for y in the other equation. Okay, so 7x plus 2y, but I'm not writing the y, equals -5. And I'm not writing it because I know what y equals. -4x minus 2. From there I solve for x. I have 7x distributes minus 8x minus 4 equals -5. From there, combine my like terms, negative x, because 7 minus 8 is -1x. And I'm going to add the 4 over to the other side right away. So negative x equals -1. That tells me that x equals 1. So I have the x part of my solution. I need the y part. I'm going to plug that value back into the equation from step 1, and that's right here. I'm going to plug x in. So y equals -4x, where x is 1, minus 2, which is -6. Now there are two other types of solutions we can get. Remember, in a system, it's either one solution, which we just got. The other type is infinite solutions. That is the case when the variables cancel out and leave a true statement. Okay, like 21 equals 21. That would be an infinite solution system. And if the variables cancel and we're left with a false statement, like 21 equals 12, that is not true. So that is no solution.